In this video, we'll be looking at another example of polynomial inequalities. This one again is a quadratic, and again the steps don't change. So the first step that we're going to do is we're going to go ahead and make sure that this thing is less than or equal to either 0 or 0 is less than or equal to the polynomial. We're going to choose that based on this x squared term. As long as it's positive, we're going to go ahead and keep all the things with that term on that side. So in this case, I'm going to add the 6x over to the other side. I'm going to add the 1 to the other side, giving me something along the lines of 2x squared plus 6x plus 1 is again less than or equal to 0. So with that step done, the next step is we're going to go ahead and assume that it was equal to 0 from the beginning, and off to the side here we'll do 2x squared plus 6x plus 1 equals to 0. We're going to solve this like we would normally with any other equation. When we're looking at this, the main steps here is, again, we're going to go ahead and attempt to factor this, but you'll notice that 2 doesn't factor nicely over the value of 6 in the middle. So we can't use that rainbow factoring that we would use in the previous examples. You could attempt to use complete the square. That could work. But again, complete the square I think is a little more complicated than you want it to be. We're going to go ahead and instead just use the quadratic formula. Because again, we're going to solve this for the locations where this polynomial could cross the x-axis, where it could change its direction. Well, not change its direction, but change its positive, negative values. So in this case, x is equal to a negative b, so negative 6. I'm going to check that in parentheses, plus or minus the square root of b, which is 6, again, squared, minus 4 times my a, which is 2, times my c, which is a 1. This is all divided by 2 times a, my a value being a 2. With this setup, now we can go ahead and just evaluate all the individual details. This is going to be negative 6 plus or minus the square root of 36 minus 8, and 36 minus 8 is going to end up giving me a 28. This is all divided by 4. I'm then going to go ahead and simplify this as much as possible, giving me negative 6 plus or minus 28. When I break it down off to the side here, will be 28, 4, and 7. 4 can break down to 2 and 2. That pair can go outside, and I'll be left with plus or minus 2 square roots of 7, all divided by 4. I can then simplify this so that the fractions are no longer there, or at least as simple as possible. In this case, giving me a negative 3 over 2 plus or minus radical 7 over 2. So you're looking here at some, again, obnoxious looking values, but these are the locations. The x value of negative 3 plus radical 7 all over 2. Sorry, that's a 7. And then x is equal to negative 3 minus radical 7 all over 2. Those are my two values where the inequality should potentially change its direction, its positive or negative sign. It doesn't have to change there, but those are the two locations where it could. Again, this is slightly straightforward in terms of the quadratic, but gets more complicated depending on the function that you're looking at. So the next step that we're going to do is we're going to go ahead and build that number line test. Remember, the number line test is built by drawing ourselves a number line, identifying the values that we're working with. Now, if you're struggling with how to set this up because these numbers are so uncomfortable looking, you can go ahead and use your calculator. Let me see here. There we go. You can use your calculator to evaluate those numbers, and then just keep in mind that these are the answers, not the approximated value from the calculator. So, for instance, negative 3 plus my square root of 7, and then I'm going to take that. I'm going to divide that whole thing by 2. That's going to give me approximating to a, let me make sure that does that correctly. Give me this one, alpha. There we go. So approximately negative 0.177 as the answer for this one. So approximately negative 0.177. And then if I do the other one, I'm going to go ahead and just take this thing again, but this time instead of having the radical 7 be positive, I'm going to chuck a negative in front of it, which is right there. I'm going to hit enter again, and I'm going to have to do the alpha again. This one over here is approximately negative 2.82. So now what's important with these is that I have the approximated values of what they are, so I know more or less where they should stand. So what I'm going to do here is I'm going to identify this one as the, again, more negative case, that negative 2.82, but again I have to label it as negative 3 minus radical 7 over 2, because that's the actual value I'm playing with, not this negative 2.28 or 2.82. This one over here is going to be, again, the less negative one, that negative 0.17. I'm going to write that down as, again, negative 3 plus radical 7 all over 2. To make sure that I feel comfortable with the values that I'm looking at, I'm going to go ahead and draw these number line, or these lines down here to create my table. But this time I'm going to leave my intervals here. Next is going to be my test values, and then again after that I'll have all of those workout problems. But to help me identify these information values, I'm going to go ahead and put a number line here and a number line here. It doesn't have to be perfect, it doesn't have to be viciously accurate. It just has to be something to give me some idea so I don't forget where those values sit. So this is negative 2.82, so this should be negative 2 on this side, and this should be negative 3 on this side. And over here to help me, again, this is negative 0.17, not negative 1.7. So this should be between 0 and a negative 1. Okay, so now I know approximately where those values sit. Again, these things should probably be spaced out better, but for right now, this is what I really want to see. So in the intervals, I'm going to go ahead and do the exact same thing I did with the last examples, negative infinity to that negative 3 minus radical 7 over 2. I'm going to do the same thing over here, negative 3 minus radical 7 over 2, comma, negative 3 plus radical 7 over 2. Notice how I'm not putting the parentheses or brackets on those edges yet. I haven't identified whether or not I need them to have parentheses or brackets yet, so I'm going to leave them off until I get to that point. Okay, with this being done, I'm going to look back at the inequality. I'm going to notice that it's supposed to be less than or equal to 0. Again, less than or equal to 0 tells me that the equal signs, I should have brackets on all of these values. Now, this is not necessarily true when we're talking about rational functions in the inequalities, which we'll get to. But for the polynomial ones, we can, again, leave this as though if I have the equality symbol here, all of my endpoints, my critical points, my special points, should have brackets on them. Now with that done, we can go ahead and pick our test values. Again, this one here, I'm going to pick negative 3 because it's the closest one on this side. Over here, I'll go ahead and stick to negative 1 because it's a nice, easy number. And over here, I'll pick 0. Again, you could pick 1 in that section. It's up to you. But again, keep in mind we have to test these values. And 0 is probably a lot easier to test than any other number. Now we're going to come back up here. In the previous example, we had this thing factored, and we could plug the values into the factored form. In this case, we're going to go ahead and avoid that, simply because there's no way to nicely write this as factored unless you're going to complete the square and make it look that way. So in this case, I could either plug it in here or plug it all the way back in here. And for the case of reinforcing the understanding that if you make a mistake in the problem going from here to here, then all your check in this section is going to be wrong. So I'm going to go ahead and plug it in into the original inequality up here. So I'm going to plug negative 3 into this 2x squared. So I'm going to have negative 3 squared is 9. 9 times 2 is 18. I'm going to write down 18. And then I'm going to plug that negative 3 into the other side. And it should be less than or equal to. When I plug in negative 3 to the other side, I get negative 6 times the negative 3. Negative 6 times the negative 3 is a positive 18. Minus the 1 is a 17. In that case, 18 is not less than 17, and that section shouldn't work. We're going to continue doing this for all the other sections relatively quickly. The first one's going to be 2 less than or equal to. I'm going to have positive 6 minus 1, so that's going to be a 5. And 5 is greater than or equal to 2, so that section checks. And then when I plug in 0, I'm going to get 0 is less than or equal to negative 1. And that's not true, so that section doesn't check. And again, all I'm doing is I'm taking those numbers and I'm plugging them into this up here. Again, you can plug it in here and check to make sure that they're less than or equal to 0. But I'm gonna plug it back in here just to verify that I feel comfortable that I made no silly mistakes in the algebra from here to here. There is a possibility that I could make a mistake with the algebra here and I still get the correct x values. It's unlikely, but it is a possibility. I'm going to go ahead and bank on that possibility working out for me. So once I'm here, the next step is for me to go ahead and simply make sure I graph my function or graph my inequality answers, as well as make sure I indicate what my function solution actually is. Now, because they're equal signs, I'm going to put solid dots on both this value and this value, and I'm going to connect them with a line in between, because that's the middle section is the only section that actually verified to work. The other two sections weren't going to work. Okay. With that being said, my final solution is going to be the middle value interval, so negative 3 plus radical 7 over 2 with the brackets on the edges, and that should be your solution for this particular inequality.